Hello. So, if you've been following along, you've probably seen me struggling to write a board game, and I'm not in a race to complete it. So, whilst I'm writing it, I'm also using it as an opportunity to kind of experiment a bit. And one of my experiments is different heuristics, different ways to score the progress of the board game. I've also been looking at how to use MiniMax to find the best AI score. Let me just run this and then I'll show you what the main focus of the video is, because the main focus of the video is actually to look at using Pytest to simulate different scores. Anyway, this is progress. It's kind of progress, but it's not perfectly working yet. So you can see in the middle of the grid, I've got 9 zeros, 3 zeros, 3 zeros, 3 zeros, and they're effectively my tic-tac-toe board, whatever you want to call it. This is not going to be tic-tac-toe. My ambition is to make this much bigger, so maybe 5 by 5, something like that. But anyway, for the time being, it's tic-tac-toe. So let's just go with choose a row between 1 and 3. So let's go for row 3, position 3. And it is kind of running MiniMax, but I think I'm giving it some bad information to base its. I think my evaluation function is flawed, so that is why I am showing this video, because in a minute we're going to go and run some tests using Pytest on some different score combinations. So 22 seconds to, yeah, that's not good, is it? Anyway, let's just finish this game off. So I'll do row 3, position 2. And the AI ran a lot quicker that time. And I think as the number of options shrinks, it gets exponentially faster. So if I go, I'm just going to let this win. So I'm just going to go for row 2, position 2. And that should say AI. So you see AI won because I had 3 in a row that, or the AI had 3 in a row there. So, but this is not by far from working yet. And so I could just copy some existing code from GitHub, but I want to write this in my own style and get it working with 100% my code, maybe with a bit of help from the original MiniMax function, which actually was from Geeks for Geeks, but I've already kind of modified it so much now it doesn't really bear a huge resemblance. So yeah, my evaluate function is looking, at the moment, it's looking for 2 in a row and 3 in a row, which is here. So I've got nested for loops, which are looking for 2 in a row, 3 in a row. I'm still undecided upon whether to actually return with a positive or a minus to reflect which player has got the highest score. I may actually obtain that from keeping a log over who was the last person to make a move. Anyway, test evaluate. This is a Pytest. Well, it's a file written in Python with a prefix of test underscore. And I've put it inside a folder called tests. And because I've installed Pytest and I've called my function test underscore, or 2 functions even, Pytest will find these and run them. So my first function is going to run the evaluate function, which Pytest comes in here, sees the evaluate function. It knows that evaluate function is inside the file dem1b. So then it goes and collects the code from dem1b. And then it uses that code it passes in board underscore m11, which is what is inside this file here, inside this array. And then it, based on the output from the evaluate function, I've set a variable, and then if that variable, I then code in what I expect the variable to be. If the function returns the same value as what I expect it to be, then the test will pass successfully. Probably not explained that brilliantly, but the focus of this video is just showing what my current thinking is with testing my evaluate function, and that is to use Pytest. So I've installed if you've not seen this before, this is cool. This is the VS Code extension to run Pytest. And you can see, so what have we got here? We've got test evaluate _1. So I'm looking for one player. Each player has made one move. So if each player has made one move, then nobody should be in a very strong position to win the game or get 3 in a row. So I could actually make that. My scoring rationale for my scoring is actually just to put 0 on the end of how many in a row. So yeah, potentially I could make that 10. But when there's only been one move of each, I don't consider that to be gaining a advantage within the game. 2 in a row, yeah, definitely. So here we go. So 1 in a row. Test evaluate 1 is what was evaluated here. Do you see test evaluate 1? So whatever I'm highlighting here matches what's across here in the code. So 2C, that's this function. If I was to complete this, I would do test evaluate. So it's test underscore, and then evaluate, which is the name of the function, which is present in my main code, board game code. And then I'm going to say I'm looking for 2 in a row, so I'll do 2R. And then I'm going to uncomment this because I've already tested this and I know that works. Oh, and it's going to complain about docstring. So check 2 in a row. And now those squiggly lines go, and I'll do def test underscore evaluate. What am I testing here? 3 in a column I'm testing here. And so I've got 4 functions, 4 test functions. It really wants these doc strings, doesn't it? 3 in a col. So I've got 4 functions, 4 test functions, and I've got 4 lots of test data. So the one, which was just one of each. There we've got 2 of the same in a column. Here we've got, yeah. So here I've got 2 in a row, 2 more in a row, and I've got 2 in a column. So this is where I think I'm having problems with my code. And for the heuristics, based on my idea that the board will not be square, I'm thinking it will be a rectangular board. I need to sit down and think whether a column is like highest scoring. So a column of 2, I need to think, is 2 in a column more powerful than 2 in a row? That's kind of, this is dependent upon what I decide the rules of the game are. So this one is subject to change. And again, 3 in a row, column, row. 3 in a column is the 4th test, and that'll be evaluate underscore 3C. So these 2 are new. So what I'm going to do is just run this again. And I've got all those lovely green ticks. So let's just go into Zen mode, and I'm just going to just give one last overview of this. So we've got, One other thing you can try is parameterize, and then you have expected results. You pass in parameters, and then you pass in the expected result. I may or may not look at that. I don't want to get too carried away by doing Pytest and testing, but for this purpose, I think this is probably going to save me a lot of time, because to test the board game at the moment, it's running the MiniMax function, which, as you saw, took 22 seconds the first time it ran, whereas Pytest took, 3 seconds to run, something like that. So if I run it here, even without using VS Code, let me just do, it's pretty much instant. Yeah, 4 passed in. Yeah, 0.07 seconds. So 0.07 seconds is a lot quicker than 0.07 seconds. Remember that, and remember that against. I think this is probably going to come out about the same time. So I know this has taken up 20 seconds of our lives, but hopefully these 20 seconds you'll always remember, and you'll think, wow, as much as I'm not the biggest fan of writing tests, if you multiply 20 seconds by, I don't know, I've probably already tested some of these bits of code maybe 20 times. 23 seconds times 20 is, what's that in minutes? That's about 8 minutes. I don't know, maybe more. Whereas with Pytest, it was 0.07 of a second. So 1 second or 8 minutes. Second time it runs, it's a lot quicker, 2 seconds. And the third time it runs, it'll be even quicker. So there we go, AI 1. So I'm making progress. I'm not rushing to finish this, because I'm trying to treat it as a learning exercise, and I'm more interested in kind of designing the game rather than just head first into the code, if that makes sense. So yeah, hopefully this has just given you some ideas and basically showed you how you can use Pytest to speed up the development of a board game. So thanks for watching, and I'll see you next time.